Okay, so in this video, I'm going to be talking through part E of the Tidewater Landing Stadium project. This is where we're going to use the numbers that we found in part D, right? Specifically, we found the profit maximizing ticket price, right? The ticket price that Tidewater or that Rhode Island FC would want to charge to make as much money as possible. That was kind of our big goal. We're going to use that to actually figure out how to answer a question of interest. Remember, question of interest is will Rhode Island FC generate enough tax revenue over the next 30 seasons in order to pay for that should be 54 million um, that they borrowed in public bonds. Um, and to do this, we'll be considering the fact that Rhode Island businesses pay 7% of tax on their revenue. So we are going to first want to figure out how much revenue Rhode Island FC will generate, then we can use that to figure out how much tax revenue they will pay. So again, because this is revenue, not profit, the way that we can figure out how much revenue they're going to take in per game, well, we know that they're going to charge this profit maximizing ticket price, right? We found that in the last step. And we also know that we have this equation here that tells us for any ticket price X, how much revenue is the team going to take it. So your first step here in for questions 1 and 2, just ask you to draw previous information, right? So for 1, you're finding the profit maximizing ticket price. For 2, you're going back and bringing down that revenue equation. And for 3, you're just plugging that value into the revenue equation to get an estimate for how much revenue they can earn in a single game. If we wanted to see what that looked like in practice, let's use the numbers from the Oliver concert problem. We found in the Oliver concert problem that the profit maximizing ticket price would be 27.50, and we know that our revenue function in this equation is negative 6x squared minus 330x. So if we have r is equal to negative 6x squared plus 330x, we know that x has to be equal to 2750. Let's plug that in. R is equal to negative 6 times 2750 squared plus 330 times 2750. You can double check my math on this, but if you do that all out, you should get 4,537.50 for your revenue. And so that is what you would put for question 3. Remember, that is the revenue that they can earn for a single game, right? For one game. But what we don't care about that one game. We care about how much tax revenue they're going to pay over the course of the next 30 years. So to do that, we're going to complete table 8 here. And the point with table 8 is that we've estimated the amount of revenue they're going to earn for one game. We're going to take that and we're going to figure out for a whole season, how much tax revenue are they going to make? And the important part here is Rhode Island FC is going to play 17 home games each season, right? That's how long their season is. So they're going to play 17 home games. So if they earn this amount of money for every one home game, and remember, that's your answer from question 3 up here, right? That's this one goes into the table right here. And if that's for one game, and we want to figure out for a whole season, which contains 17 games, you want to take that number, multiply it by 17, and that gives you the number here. After you've done that, we want to think about, well, how many taxes are they going to pay in that whole season, right? If they earn this amount of revenue each season, and they pay the 7% tax rate, right? 7% tax on their revenue. If we multiply that by 0.7, right, if we take 7% of it, this will be the amount of tax revenue that Rhode Island FC will pay each season, right, each season. And we're going to be paying the bonds back, the 54 million in public bonds, over the next 30 years. So we're going to want to multiply that by 30, and that'll give us an estimate for how much tax revenue is Rhode Island FC going to be generating over the next 30 years. And that will help us answer the question of, will it be worth it? Was it worth it to borrow the $54 million to construct the stadium? Once we have done that, we're going to take a step back and think about how realistic is that? How much can we actually trust this answer that we got, right? Our model's going to spit out an answer here, and it's either going to be bigger or smaller than 54 million, meaning that if it's bigger, then it was a good investment. If it's smaller, then it wasn't. But remember, our model is not completely accurate, right? Specifically, we had to make simplifications of real life in order to represent it using the math that we wanted to use. So now let's take a step back and let's think about how realistic were those simplifications, right? Is this a good model to represent the situation? Because if this is a good model, then we want to trust our answer. But if it's not, then maybe we want to have some doubts, right? We're trying to explore a real world situation here using a very simplified model. And so in this table, you're going to want to find 5 false assumptions. And what's meant by a false assumption is it's something that our model assumes to be true about the situation, right? Something that the model says, yeah, the situation works like this. But in reality, it's a lot more complicated than that, right? So these are things that like the model is taking to be true that may not actually be true when thinking about real life. So I have one example listed here. In our model, each ticket costs X dollars, right? That was one of the first things we defined. We said let X be the ticket price. In reality, though, not every ticket costs X dollars, right? In real life, the cost of tickets are different for different games and vary depending on how good the seat is, right? Just because you buy a ticket to a game on a Tuesday night doesn't mean you're going to pay the same price as if you went to a ticket Saturday afternoon or pay for a game on Saturday afternoon. Or those prices are going to be different. Same with if you're sitting midfield, like right next to the pitch, you're probably going to be paying more than if you're sitting way up in the nosebleeds, right? So in reality, ticket prices vary depending on where you are located. So for this table, you're thinking about what are 5 different ways that our model simplifies reality and why does it not represent real life, right? So you're putting what does the model assume to be true over here? And why is that a simplification of real life? Why is the real world more complicated than that? And we did a lot of simplifications, right? So there are probably dozens, if not hundreds, of simplifications that we could write here, right? This is a very complicated problem, and we represented it using, a fairly complicated model, but nowhere near as complicated as real life actually is. Once you've done that, I want you to pick one of the false assumptions that you identified on the previous page and just think about how could the model be improved to be more realistic. Right? You don't need to actually like change the model, come up with any equations, anything like that. I just want you to think through what is something that we could do to make the model work better. So for example, if I said each ticket costs X dollars and in real life, different depending on the games and vary on how good the seat is, if I wanted to make our model more realistic, then I could create several different demand functions for different types of tickets, right? I could be like, here is a demand function for really good seats, and here is a demand function for, kind of less expensive seats. And so I could make it more complicated, but also more realistic by having multiple demand functions for each of the different tickets. That would just be one example. What you're doing is you're finding one thing, one false assumption, one thing that the model assumes to be true that isn't. You're thinking about how can the model be changed to make it more realistic.